presented with the connection. We'll accept that. We see that it's loading the software. And we're presented with the ASDM landing page. Here on the device dashboard, there is a lot of useful information about the device itself, as far as traffic statistics, interface status, system resources. Got a little breakdown of the VPN sessions, syslog messages, device information, and licensing information. Very important, since the ASA is a licensed platform and your features will depend on the license which you've purchased and applied. You can see our host name, our version, the ASDM version, the firewall mode and flash, uptime, device type, context mode, and the memory available to us. We can see that the traffic is active because we're running that ICMP continuous ping, and we can see down here in the syslog messages, if I stop this, we can see the connections building from our laptop over to the interface of the ASA itself. So right when you log in, you can see if there's any sort of faults, if you're getting pegged CPU or memory, if the traffic looks suspiciously high. You can take a look at the VPN sessions and get a really quick overview of your interface statuses. The Firewall Dashboard gives a little bit more information about connection statistics, usage stats. We can see all of the packets. The connections here are top 10 sources, so we're pinging from the laptop, which would be classified as a destination from the viewpoint of the ASA, since it's responding back to the laptop, 172.16.1.2. So our source is 192.168.2.2. We don't have the services feature enabled, and we're not too concerned about that at this point. So we'll just leave that alone and move on to the monitoring section of the ASA. We have the ARP table, the dynamic ARP entries here. Very small ARP table. We can see the DHCP, client and server statistics, any sort of dynamic ACLs that have been created. There are interface graphs available so we can run reports about the interfaces. IPv6 functionality and PPPoE client functionality. And this is all under the interfaces section. There's a section for VPN as well, routing, some of the device properties, so the AAA server, there's a local database, some of the device access methods and statistics. We can see that we've been connected here from 172.16.1.2 via the ASDM and HTTPS, connection graphs, the translations, performance, certificate, revocation, system resource graphs, WCCP. So there's a lot of useful information here in the GUI. The ASA is one of the devices that I do like. I do like the GUI. I like to manage firewalls generally through a GUI. It's just a little bit easier on the eyes when you're creating the policy and grouping things together or laying things out. It's not to say that the CLI is not needed or not necessary, but I just feel like the GUI, in my opinion, helps keep things a little bit more tidy. We also have the logging section where we can view the real-time log. We can see those pings coming through, and this is just a larger view of what we saw on the landing page on the dashboard itself, the device dashboard. We can see the severity of the message, the timestamp, the syslog ID, and it gives a brief explanation of what that ID means. We can see the source IP and port, and destination IP and port, and a description. And then also down at the bottom here, we can see some syslog details, which give the syntax of the connection itself. So the description here, you can see it's built an inbound ICMP connection from this IP address to this IP address. And you can see down here, there it correlates. This is the syslog message itself and how it's structured. So the syntax for the message itself is listed. And that can be pretty helpful if something is new or it looks out of the ordinary, you should be able to glean some degree of information from the logs and then take that to Cisco.com or the internet and get a little bit more detail if it's something that you're attempting to troubleshoot. You can also view the log buffer, which is all the messages that have been stored within the device buffer. So we won't get too much into this at this point. There is a VPN video where we talk about SSL VPNs and we verify the client-based SSL VPN AnyConnect and look at a little bit of what that looks like when you have a connection that's logged and ongoing. For the configuration portion of this lab, let's jump over to the device setup itself and look at what's available to us. Very similar to the CCP, you can see there's a breakdown of the interfaces and their configuration. There are our routing methods, so we can see the static route that we put in, any sort of route maps, prefix rules, the dynamic routing protocols and multicast, the device name, domain name, password, system time settings, and ether channel. Under the firewall portion, you see here it looks a little bit cluttered, and that's mainly because right down here we can view IPv4 and IPv6 rules. There's no IPv6 that applies to this lab or what we're doing here, so I will just select IPv4 and remove about half of that clutter. What I was speaking to earlier regarding the zones, you can see by default the flow inside zone is going to allow a source of any to a destination of any less secure networks. So outside would be the only other interface that we have. So the inside interface is going to allow anything outbound by default. It's going to permit that. It's an implied rule, and that's on any service. So outside, you can see there's no rule under the outside. And under the global rule, it's an implicit deny. So the traffic on the outside would be denied back inbound. Before we go any further, we'll be testing using connections from the laptop over to the web server. So we will configure the web server with an IP address and a gateway. Our, IP address and our default gateway. Let's see if we can ping through. Look at our logs and see if we can view the traffic and see if it's hitting the firewall. Let's make this continuous. Okay. Doesn't look like the traffic is making it to the firewall. So let's look at the router. Oh, okay. I think I might actually know what the problem is. It might be a local routing issue. I have static routes for these networks for the 192.168, and there should be one for the 10.1.1.0 that specify to use the loopback, but I don't think I have that route present at the moment. Nope. So I'll need to do a route add for 10.1.1. Okay, now we can see. Their connections are actually, so you can see they're being allowed outbound and they're being denied from the server back inbound. That's because ICMP by the firewall is seen as non-stateful, so that connection that's built from the web server back is seen as a new connection. If I were to try telnet, we can see that it opened up that connection because the firewall saw that TCP connection as stateful and allowed it. And we did, okay, we can see where the connection was built right here. And then torn down. If I'm a client attempting to telnet to the server on a port it's not listening on, you can see that we receive a reset message from the server itself. If there's maybe some sort of issue with, let's remove, let's see if we can delete this. Okay, so there's no default gateway and the server shouldn't be able to respond back saying that it was giving a connection refused message, basically saying I'm not listening on that port. It's allowed through the firewall, but the destination isn't listening on that port, so it returns a reset. In this case, we should see a send timeout since the traffic is blocked. If you are in the real world attempting to troubleshoot something, those are two very important things to note. If you have a client who's reporting a connectivity issue and they're saying that it just comes back with an immediate connection timeout, it may not, Windows or whatever operating system they're using, may not see that as a connection refused message. They'll see it as a timeout, even though it didn't hit the 30-second timeout. It wasn't actually returned as a send timeout. In this case, since the server doesn't have a route, that default route, it will be a timeout since there was never any sort of response from the server. that could be more of an indication of a networking issue, obviously. What I like to do in that case is if the client is saying that they're seeing an immediate refusal from the destination server, it's a pretty good indication that routing and firewalls and in the path are configured properly, but there's likely an issue with the destination server itself. When I run into that issue, I like to go all the way to, as close as I can to the destination, perhaps even on the device where the SVI sits for the destination network, and try and do a telnet from the destination network itself to the server and see if from the local LAN I can get a response. If I can get a response, but it times out for the client, then clearly there's something in the path that's blocking that, be it routing or a firewall issue. But if I'm getting a connection refused from the directly connected SVI, then that's telling me that there's an issue with the server. It's not listening on that service, or there's some sort of malfunction. That was kind of a side note, but it very, very useful when it comes to troubleshooting for folks. So we look at the policy and we can see, once again, any source from the inside to any less secure network is allowed, and connections from the outside in are denied. Clearly seen with the example there, we could see that ICMP was blocked. Now if I go back in and add this route and then perform the ping, we can see those denies. Let's say we want to add a rule that allows a source of 10.1.1.150. Well, let's create this in an object, actually, a named object. So if we want to create a source object, this will be a host object network. The name, we'll call this server 10.1.150, and this will be a host, the IP address obviously 10.1.1.150. Okay, so we'll select that as our source, and our destination will be the laptop 172.16.1.2. And we'll say ICMP. We'll enable logging. And just after we apply the rule, we see that now the traffic is flowing. So the specific rule that we put in is now allowing the traffic. The next thing that I would like to do is demonstrate a NAT using PAT, port address translation, or NAT overload as it's commonly known. The application for this scenario is, let's say the web server, this guy right here, again does not have, we'll remove the default route. Let's go in here and remove the default route. And what we're going to do is translate our source, say it's going outbound, and we want to hide it behind the IP address of ETH0 so that it's on the same LAN as the web server. That way the web server doesn't need to know about our private network. It will see the source originating through the ASA as the IP address of the ASA itself, which the web server already knows about since it has an IP address on that LAN. So there's no special routing needed, there's no default gateway needed. The web server will simply be responding back to the 10.1.1.1 on the ASA, and the ASA will translate that and then respond back to the laptop. In order to do so, we go over to our Nat Rule section. We're going to add source interface inside. Say the source IP address will be our laptop. Destination interface will be outside, and our destination will be server on any service. We could specify ICMP, HTTP, whatever service applies, but we'll just leave it as any in this particular case. We're going to do this as a dynamic PAT or hide NAT or NAT overload. So the source address, we will use the outside interface as our source, translated source address. So that means as our traffic flows through the ASA, it will be hidden behind the IP address configured on our outside interface. And we'll leave our destination, service, and address alone. We will enable this rule, hit OK, and apply. We can see the command here that it's sending down. It's going to NAT. Inside to outside, it's going to be a source of our object here using the interface. Destination static NAT to the server. Send. And once again, we can see our traffic is again flowing. And when we bring up the log, we can see that the connection seen by the firewall, we can see it's built the translation from 172.16.1.2 to the outside of 10.1.1.1. And we can see the ICMP connection, which is built from 10.1.1.1 to 10.1.1.150. If we go to monitoring, let's see. Trying to find the NAT. Okay, here's a graph showing the translates, xlates rather. And we can see there were no translates which occurred until we applied the rule. And then you can see there's that single translation that continues to occur as our continuous ping progresses. The other type of NAT that we can do is an object-based NAT. Let's go ahead and delete this. Well, let's use another IP address. We'll do a destination NAT this time, so we'll delete this NAT rule. We'll restore routing. But we're going to change, this IP. We'll assign a different IP for the web server, and we'll translate from the destination. So let's say we're going to contact just come up with the 1, 2, 3, 4, 5, 6, 7 /32. This is a new IP address that we were given, which we need to use to contact the web server. So we'll configure a NAT on the ASA saying any traffic coming from the laptop destined for this IP will be translated to the web server. We'll need to put in we'll need to put in routing locally just for this particular case to say for this specific traffic, redirect it through router 1, through that loopback interface. So we're adding a route for that IP, 32-bit mask, saying that in order to get to that IP, you need to use the the local loopback adapter that's being routed into GNS3. So we'll start that continuous ping, jump back over to the ASDM. We'll add a new NAT. So the source interface will be the inside. Source address will be the laptop. Destination interface will be the outside. And let's see, we'll create an object for that new NAT. So we'll call it NAT 1, 2, 3, 4, 5, 6, 7. So there's also the ability to do a NAT within the object itself. And maybe we should demonstrate that. I'll show you how you could do it here, but we'll go ahead and proceed with adding the Nat Rule to the section, the Nat Rule section, rather than doing it within the object itself. So we could do a static translation for this within the object itself. We could translate it to the server IP. So this would say, we're adding this network object, which is this IP, but it's going to be translated to the server IP. Does that make sense? We're doing the NAT within the object itself, rather than creating a separate NAT rule. And then if this object is referenced, let's just go ahead and do it that way. We'll cancel this and go over to the access rules. And we will add a new rule for the laptop to our new object, the NAT object. And we will translate it to the server. Okay. So this rule is saying allow this connection from the laptop to this IP on any service, log it, and it should perform that NAT within the object itself. suspect there is some sort of, oh, okay, the router. Well, it should be allowing that. Oh, that's it. No, it's has a static default route. Oh, let me plug in my laptop here. Hi, sorry about the disruption there. I was looking a little bit more at how this functionality works and how it should work and the expected result, and it wasn't, it was getting a failure to locate the egress interface when I was doing the object NAT. So I went in and created an actual static NAT rule like we did before, and it is working. So I'm not sure if maybe there's, it might be some sort of routing issue with the topology that I'm using. But when I did the embedded object NAT, it was giving me a failure to locate the egress interface. When I went in and created a specific NAT rule, even though within the object I had specified that it should be the inside, the source is the inside and the destination is the outside, it was still giving me that error. However, when I came in and made the specific NAT rule itself, and I specify the inside of our laptop and the outside to the NAT, and we can see this is just a plain object right now with an IP. It's a host object. There's no NAT involved here. I cleared that configuration, and it's just a straight up IP address. We're going to leave the source the same, and we'll be performing a static NAT, but the destination, we'll be translating it to the server IP and leaving the service alone, and we are enabling the rule. So the rule is enabled, and we can see now that our ping attempts to the NAT IP address are working, and it is being translated. So let's go ahead and kick that off again. And we see that the actual connection seen by the ASA itself is from the source IP to the final destination. We're not seeing the NAT IP address in here. So the object-based NAT is possible. I ran into that problem. Not sure if maybe it's something to do with GNS3 or the way that I was performing it. I know I've done it in the past and not run into issues with it, but in this case it wasn't working out, and I think it may be related to the way that I have the topology set up and the way the routing is configured. A little bit of recap. We did the two NAT situations there. We did a PAT, a hide NAT, where we overloaded using the outside interface and removed the default gateway from the server. So the IP that was seen by the web server was that of the outside interface of the ASA. We also did another scenario where we used what could be a public IP address, and where, let's say, this firewall is the absolute closest to the destination, it would be translating a public IP address to a private IP. So there was a 123.4.56.7 configured, and that's what we're hitting on the interface of the ASA, the inside. And then once the ASA sees a connection that matches 172.16.1.2 destined to the 123.4.56.7, it would translate that to the web server. It's going to replace the destination IP with the IP of the web server, and we can see that once that was done, the traffic is now flowing. We also looked at some of the features available on the ASA. We can see there's remote access VPNs, client-based and clientless, site-to-site VPNs that we can also create. And there are several device management features as well. So looking into the management access of the device, we previously configured the HTTPS option for the inside interface to be managed by the 172.16.1.0/30 network. We did that through the command line, but you can see in the GUI where that actually appears. There's specific management interfaces that we can designate. There's SNMP parameters that we can configure and management access rules. We also have the licensing section here, very important. The system image and boot configurations, our login setups. So if we would like to enable login, buffer size, ASDM login, we can email based upon syslog events and lists that we create. We can also create filters. We can filter out or disable certain syslog messages. We can see all the different syslog IDs here. You can look up syslog IDs online and see what the actual ID means. And when I say ID, if you look right here, a syslog ID column, you can find that correlating ID in the list and disable it if you would like to suppress a certain message. There's the call home feature, our users, there's the local user database, certificate management, DHCP, DNS, and some advanced features like WCCP. We've used that in the past, and various other settings that the ASA allows you to tweak. It's fairly robust, straightforward, easy to use. The best way to get familiar with it is to just poke around. Having this functionality within GNS3 is incredibly valuable since the ASA is definitely not a cheap platform like most of the Cisco platforms out there, but having the ability to simulate the ASA and then connect in using the ASDM through that loopback is just really great functionality that we have now. So I would like to thank you for spending this time with me. We reviewed the Cisco Configuration Professional and zone-based firewalls. We created inside zone and outside zone. Created a zone pair from the inside to the outside. We configured it to inspect traffic. We had also configured it to allow, and we saw where allowing traffic does not enable stateful inspection. So when we're allowing traffic, we would need an inverse rule configured from the outside to the inside. We don't have that configured here, so we saw that traffic fail. However, when we configured it to inspect the traffic, it was allowed regardless of the fact that there's an outside to inside zone. There's no outside to inside zone pair configured, and there's no policy for traffic that flows from the outside networks in. Thank you for spending time with me on this video. I hope you have the ability to go into the lab, reproduce this, tweak it, customize it, and make it your own. Work on that object-based NAT. I'm going to look at that a little bit more. And if I have any sort of useful update or information, I'll post a quick video once I get that. But feel free to send me an email, bowlermj@yahoo.com. You can check out my YouTube channel, my brother's YouTube channel, or our .com website, bowlercbtlabs.com. Thanks again, and happy labbing.